was, bingo. Here's another thing. See, normally, when I do this lesson, I haven't shown the kids the shortcut yet. But you guys have seen the powers rule as it plays out. Because what we're really looking at here is, we're looking for the instantaneous rate. The instantaneous rate of change, not the average rate of change. Average rate of change is described slope. Instantaneous rate of change, so I leave out syllables, instantaneous rate of change is the slope of a tangent line. Instantaneous rate of change is the slope of a tangent line. Average rate of change is the slope of a secant line. If all you're looking at is a line, they're the same thing, as Joey pointed out yesterday when we were talking about this stuff. To find the slope of a tangent line, well, given f of x equals 3,000 x minus 4 squared, f prime of x, I'm going to write this the long way first, is actually the limit as h approaches 0 of 3,000 times x plus h minus 4 squared minus 3,000 x minus 4 squared over h. Does anyone want to square this trinomial, square this binomial? Hope all the x terms disappear and everything left has an h in it, factor out the h's, and then...
No, we know that's just going to be 2x.
Oh, well, a little bit. Now remember, I gave you a rule for monomials,
Oh, sorry.
and I told you that that rule for monomials would work for polynomials, for sums of monomials.
Oh.
Is this written in that form?
No.
Okay, there is a way to do that. Be brutally honest with you, you probably would have gotten the right answer anyway with what you were about to do, but not for reasons why.
Okay, so let me...
Yeah, so let's do it so now I'm going to say here, but I do want you to remember this limit definition of the derivative. I'm going to say f of x equals 3,000 times x squared minus 8x plus 16.
Wait, did you just make this? Oh, okay.
Foiled that. Foiled that one. X minus 4 times x minus 4. Did I do so correctly? Please double check me. Now, I'm going to say that f of x equals 3,000 x squared minus 24,000 x plus 48,000. Do I now have a series of monomials?
Yeah.
Okay. There are other things to do in other situations, but I've only given you one rule, and I just want you guys to be thinking, do I have the right rule to find a derivative with a shortcut for each thing in front of me? That's just sort of a habit I want you to get into. All right, Joey, follow me back over here. Okay, so if I start with f of x equals 3,000x squared minus 24,000x plus 48,000. By the rule we talked about yesterday, what will f prime of x be?
2 times so 6,000.
6,000.
Oh, wow. 2,000 minus 24,000 and then leave out the rest.
Yep. Bring down the 2. Exponent reduces by 1. If you're looking at a linear term, if you like the geometric way of thinking about this, this is what's called a linear term, because by itself it would be a line. In a linear term, the variable goes away. If you prefer the formulaic way of looking at it, this is x to the 1. 1 times negative 24,000. This exponent has 1 subtracted from it, so it goes from being x to the first to x to the 0. And what is x to the 0?
1.
1. This is my constant term. Yep. Constant, the very word constant. It means unchanging. So if it's not changing, it has no derivative, because the derivative is all about describing change. if Joey is indeed interested in how fast my fist was moving a few minutes ago, at what moment would he have been most interested? When it hit him. Now I started moving at 4 seconds, and we're oversimplifying the model a bit, but let's just say the contact was at 4.1. I know it really wasn't because I followed through and went further than it, but let's just talk about if that model was perfectly accurate. What I would be interested in is f prime of 4.1.
So remember just how
Yep, so that's 6,000 times 4.1 minus 24,000. And what would that be?
Oh my god, that's 600.
Think that's a coincidence, kid?
No. Well, inches per second.
Inches per second. Which was easier, by the way, rolling through all that data or this? Okay. Rolling through all that data is a useful exercise for 2 reasons. 1, sometimes you don't have a model. Sometimes all you have is data. And if your data is closely packed enough together, you can use data to estimate the derivative. That comes up more next year and a little bit this year. I wanted to introduce the idea that was possible. 2, not everything can be modeled by a polynomial, and not everything can be derived easily or, well, I'll leave it at that. Sometimes you're in a situation where modeling this situation is not an easy way to go.
So I could have saved my hand and not ridden for the fact.
Well, I'm going to give you some situations where you're not going to have a model and you're going to have data, and you have to estimate derivatives anyway. Because the important thing is, that's where kids get lost in this. It's really easy to learn the shortcuts of calculus. Literally 80% of what you need from a formulaic standpoint is on a t-shirt I have at home. And no, I can't wear it the day of the AP exam and proctor your exam. And you can't wear it either.
Wait, why can't we wear it?
They actually put the rule in about helpful clothing hints are not allowed on AP exams.
But what if
Like
you
they're
had
t-shirts of the Constitution, you can't wear it to the AP US.
DKNY t-shirt and like you had a mnemonic device to help you remember things?
I don't think that's covered at all, so I think you're fine.
But
But wow, that's interesting.
That's very
Yeah.
specific.
What if you had tattooed
Okay, I don't even
on
know, and I'm not even going to worry about it.
Just have like random letters on
Okay,
your shirt.
But at any rate, my original point was all the little formulas for calculus literally fit on a t-shirt. Almost everything you need for AP calculus. The thing is, when do you use them? What do you do when you don't have a good model? What do you do when you have to come up with the model yourself? Also applying them. When we were plugging in, when I was plugging values into this, what was that telling me? When I plugged in time was my input, what was my output of that function? What did I get? What did that tell me? Where was this? This was, what did you start to say? Distance. Actually displacement, but yeah, we'll say distance. I plugged into this function. When I put t in, that told me how many inches my fist had gone. That's what that 24.6 was, 24 points or whatever it was. Those were actual positions in inches we were finding there, okay? When I plugged into the derivative, 6,000x minus 24,000, I put in time, what did I get? I got an instantaneous velocity. Not just damage, you're right, I got a speed. I got a speed, I got a velocity, I got an instantaneous velocity. Very common mistake in AP calculus next year is a kid can look at a model, find a derivative, and not pay attention to what you're plugging into what and what it means. Does that make sense? Yeah, so you gotta be aware of that kind of stuff. But I mean, the formulaic stuff, the stuff you did like last night, find the derivative, that will not be the problem. Knowing when to use which formula would be slightly an issue. I mean, the powers rule works for all polynomials. I also told you it works for non-polynomials as long as you have x to any power. And that power is a number, not a variable. It can be a negative number, it can be anything. But
This is a good question. They don't give you a formula.
no, they don't. But not only that, I want to stress the limits to what we learned yesterday. Michelle, you were very smart to remember that we could use the powers rule to answer the question. You remembered that a derivative would give us an instantaneous rate. That was beautiful. But you started to try and figure out how to use the derivative here, when yesterday I had only given you a formula that worked for monomials. This is not a string of monomials. There are other rules. There's something called the chain rule that would have made this a little bit easier. That we won't get to this year. That'll start next year. But so you got to remember, if you have a rule for monomials, don't use it here. If you have a rule for polynomials, don't use it with a logarithm. That sort of stuff will come up a lot. And also, are you being asked a question about the original function or its derivative? And if the original function means displacement, the derivative is velocity. Later on you learn if the original function is velocity, the derivative is acceleration. If the original term is...
So we didn't find that doesn't answer that.
Oh yeah, now if you wanted to know how fast my fist was accelerating at any moment, f double prime of x, 6,000x minus 24,000, go to f prime, take the derivative again. What's the derivative of this monomial? Take the derivative of that one with the rule we learned yesterday.
So 6.
And what's the derivative of any number? Nothing. So, if that was an accurate model, that would have described an acceleration of 6,000 inches per second squared. Certain parts of physics earlier this year would have been a lot easier if you guys already knew this. But you didn't, yes. I wouldn't have given you 3 formulas, I would have given you 1 formula and said, find your own damn velocity and acceleration by deriving. Any questions on this? Going once?
I mean, can you give an example of like what kind of problems on homework? Like, how did you apply this on homework?
How did you apply this? Let's see if I. Okay, I'll do one. Joey, follow me back to here. I'm making this one up, so I apologize if it's not. I'm sorry, this example is horrible. So, example. Okay, I won't make it what I originally was going to. I am making this example up so anyone watching this.
Oh my god, is he gonna kill us so?
it's gonna be fine.
Is.
All right,
I
well.
love how you laugh. Why don't you draw a little trampoline at the bottom?
Well, that's the
That
point.
makes it
No,
more
but I think
YouTube
it's gonna
friendly.
change that, doesn't it? What on it?
Here's the trampoline.
More YouTube friendly.
Oh, no, it's
Okay.
a pool. He's diving into a pool.
Oh,
No,
okay.
it's one, I need 2 different possible landings.
Oh.
Here's a trampoline, okay? Here's a person. I'm gonna say he's. I'm gonna mess this up. There's are numbers I could pick that would make this work perfectly. But I'm,
Just do one of them.
no, I'm not doing that. I'm gonna say his height is 128 feet. Okay? And I'm gonna tell you for an object that just falls and does not jump or is launched, this is similar to something you use, but I'm not being metric, Michelle and Joey, so it'll look a little different. That if a falling object, his height at any moment is negative 16 t squared plus your initial height. You guys got this free fall, except this was 1/2 g, which in metric was 4.905 or something, 4.9-ish meters per second squared. This is a feet per second squared acceleration. The trampoline, I'm going to say, is at 32 feet.
That's like tough though, because if it's a trampoline, then when like his feet touch it, it's gonna go down more.
We're not going to get that deep into the weeds for this one, so don't worry about it. Okay. A. Assuming this daredevil just falls. You know, he doesn't like a swan dive. He doesn't get a running leap or anything, because then we need our general launch equations that we did in physics. Assuming he just falls, with what instantaneous rate will he hit the trampoline? Random other question. How high will he be at 0.25 seconds after he falls? And C, here's the horrifying one, Jen, sorry. If he misses the trampoline,
Oh, he died in the rocks.
on the trampoline, yes.
I'll go take for the rest.
With what instantaneous,
We can make a pool under the trampoline. That makes it awesome.
okay, rate will he hit the pool under the
Or you can
trampoline?
do it like how at those gymnastics places they have the foam.
The foam pits?
Yeah.
You can still hurt yourself in those. It's hard. I managed to miss one once.
Well, that's tough.
I'm not really proud of that, actually. I managed to launch myself across it, demonstrating a front layout full twist off of a mini trampoline.
Well, just the fact that you could do a proper.
Oh, Michelle, you're always so nice. Yeah. I wound up finishing coaching that night with an ice pack on my head. All right, Joey, follow me back. Can you follow me to the point where you still see the questions, but also this half of this board? You do that right, you've got a cinematography job in your future. Or at least a second assistant cameraman job in your future.
We could do that.
For local television.
For local television. Oh, that's sad. All right. Okay. Assuming he just falls, with what instantaneous rate will he hit the trampoline? Okay, well, his height, which is an actual position, is negative 16t squared plus height initial. In this case, I gave you a height initial, which was
128.
128. Okay? I made this much harder than I meant to for one reason, but I think I still have time to finish it. Because, okay, his instantaneous rate at any moment is h prime equals negative 16 times 2, negative 32t. Now here's where this problem is harder than it looks at first. Did I give you a time at which he would reach the trampoline? No, I gave you a height at which he would reach the trampoline.
But you did in question B, you said high.
So we just find the
How
time
high
and then
will you be
plug
at
that
22%?
time back into what?
Yeah, well that actually shouldn't relate unless that's a really crazy coincidence. So what is the t we need? Well, we need the t, see, okay, to find the instantaneous rate you should think derivative. And we did that. To find how much time has passed when he's fallen from 128 to 32 feet, we need to go back to the originals. This is a little bit of that judgment I was talking about. Which equation do you use for what? Well, if we go back to the original one and say 32 feet equals negative 16t squared plus 128. I'm going to leave out the units for this just because of time. Bless you. Well, I'm going to get negative 96 equals negative 16t squared, right? So t squared is going to be negative 96 over negative 16, or positive 48 over 8, or positive 6. So t is going to be root 6 seconds. Does that make sense? So what is his instantaneous velocity when he hits it? H prime at this moment in time is negative 32 times the square root of 6 feet per second. Yeah, that's a good calculator time.
I got negative 78.4.
Negative 78.4 feet per second. So that's about 25 meters per second.
Why are we doing this in feet?
Because Jen hasn't seen the meter stuff before, and I thought I could make the numbers more neatly, but I blew it on here.
What meters?
Normally in physics we use meters.
I mean, yeah, it's gravity's 9.81 meters per second squared. But I thought I'd keep the numbers similar.
It's like the only number I've memorized.
And I'm not
I don't
letting
know
you pull
what
it
feet
out
per
here.
second means.
Alright, well that's why I said this is meters per second. This is about 25 meters per second, which is, well, you're looking at car through a residential neighborhood speeds, maybe a little faster than that. So, yes, that's pretty fast to hit trampoline.
It's on another planet.
Right, but that's, no, this is the gravity on Earth. So, to find this, we had to use the displacement equation to get the amount of time it would take to fall that 96 feet. And then we had plug that time into the derivative equation. Does that give you an idea how that judgment sort of works? And then the next question, Joey, go ahead and follow me over this way more. So I have to erase. But don't worry for that back. For B, and sometimes the AP test will do that, and sometimes the homework, or sometimes I'll do this. This is like an Algebra 2 question now, because how high will it be at 0.25 seconds?
You just plug 0.25 seconds for the time.
Yeah.
Those are
0.2.
the questions we like.
I'm glad you do.
Now you make it feel like it's a
So that's negative 16 times 1/4 squared. 1/4 squared, of course, is 1 over 16, so that's just negative 1 plus 128. So he'll only be at 127 feet, if I've done that right. Did I do that right? Looks right to me. So if you get a question like that, don't start throwing the calculus around. So you got to be able to read whether, and the homework tonight will say position or velocity, which one they're asking for, and you have to go like, oh, position, Algebra 2, velocity, calculus. Does that make sense? Question C, if he misses the trampoline, with what instantaneous rate will he hit the pool under the trampoline? Well, now what we have to do is find the time it takes to fall all 128 feet. If he's at 128 feet high, when he hits basically the ground level, what's his height?
minus.
No, that'd be if he fell through the ground and kept going.
We owe 0.
I'm phrasing the question poorly, yeah. Basically, when he's at a height of 0 is when he hits the pool. So that's 0 feet equals negative 16t squared plus 128. So negative 128 equals negative 16t squared. T squared then is negative 128 over negative 16, which is 8 seconds. So T is, yeah, 2√2 when you're done rationalizing it. Seconds. We go back to our derivative, which we already found. We know that h prime is just negative 32t. So he's going to hit it at 2√2 seconds with negative, it's going to be negative 64√2 seconds, so that's about 90-ish. Negative 90.5 feet per second. That's a lot faster. He really wants to hit that trampoline. Yes, I was going to have him hit concrete, I won't lie. That was my original plan for the problem. But yeah, that's what happens when I make it up off the top of my head. I lose judgment. Thank you.
You should have drawn cards.
Please don't.
You could have been like, that one is a bed of nails, and that is the street of love.
Wait do you take some of my physics tests?
Are you taking physics tests too?
Oh, you're missing out.
Yeah.
Rocks,
like
I
a
might
question.
probably.
But do you guys get the idea of the judgment you need to know whether you're being asked an algebra question or a calculus question, or whether you have to do a bit of algebra, for example, to find a time so that you can go back and answer the calculus question? Think that'll be helpful, Jen? Okay. Your homework tonight is page 958, 46, 47, 49. I think 46 is very straightforward. I think 49 is going to seem straightforward since we did this. 47 is meant to stump you a little bit, but I'm curious if it will. I think some of you will surprise me pleasantly. Questions, comments, concerns, or compliments?
So velocity is the
The derivative of position.
No, yeah, and position and element.
Yeah, for this sort of thing.
Should we start?
Yeah, you can go ahead and kill it.
What's